I've already been introduced, but my name's Ryan. I'm the author of SolidJS, and I want to talk today about a phenomenon that's been going around front-end world for the past few years. Signals, of course. And if you're not already familiar, I'm sorry to say this talk is not exactly an introduction to them. I've given that talk a few times the past few years. To summarize, I explain them like a spreadsheet. Normal assignment represents a moment in time. It means that upon completion, A reflects current sum, like a B and C here in this picture. But if either B or C change, you have to do the assignment again. The relationship doesn't hold. However, with reactivity, it does. A will always reflect the sum of B and C. Signals are a set of primitives to represent the synchronization. At its core, you just need to know three. Reactive state, also known as our namesake, signals, which is the atomic data that's tracked. Derived state, in Solid we call these memos, others call them computeds, and then finally side effects, which is how we impact our world. Straightforward enough in concept, maybe even familiar looking, but the consequences of using them go way beyond this. It's no secret at this point when I open sourced SolidJS in 2018, signals were the furthest probably from most people's minds. They'd been around in JavaScript for a better part of like a decade, but had fallen completely out of favor thanks to React's component model. Even the few libraries and frameworks that use signals that had survived sort of hid them away under plain looking objects. But with SolidJS, that all changed. And while we can't take complete credit for the shift, I'd say React's announcement of hooks shortly after that was saying like, hey, data primitives are okay, was really instrumental. It's hard to ignore the impact when pretty much every framework other than React has adopted signals first class. So great, end of story, right? Now, signals are just the beginning of a much bigger change, and I'm not alone in this thinking. The post above here is the developers responsible for bringing signals to Angular. We are at the precipice of the biggest revolution in how front-end UIs have worked in over a decade. And I don't mean AI. AI makes things easier to build, but it can only use mechanisms available to it. The way things are today, people still need to work on the low-level architecture problems if they want to be able to get the most out of their applications. So what do I mean by that? Signals are not new. You've been able to use them in every framework for years, even React, remember MobX? So what's the big deal? Just having signals aren't enough. Signals are a mechanism for change, but how you use them makes all the difference. I'm going to approach this in a few different directions, but the common thread of what makes signals so powerful is the knowledge of the data graph that powers your application. With that, we can do incredible things. We wouldn't be able to do easily otherwise. I'm going to talk today a lot about the future. Many of the code examples will be referencing upcoming features in Solid that haven't officially been released yet, so just keep that in mind. Let's start talking about performance, as that's both the easiest thing to highlight and arguably the least important. This starts with debunking a common misconception. I'm using signals, so my app framework must be faster. Unfortunately, it doesn't really work that way. Adding signals, like adding any sort of state management, actually lowers the performance ceiling of your framework. Like the React compiler, it might allow you to write more optimal code, but it doesn't have a meaningful impact on absolute performance. This is an excerpt from the JS Framework benchmark, but it's also pretty intuitive to realize this case. Adding MobX or Legend State or Jotai or Redux or whatever you want to React, or even adding signals to Preact isn't guaranteed to improve the performance in all cases. In fact, on average, it actually makes it slower because even with the signals, they still have a whole system for doing updates with the virtual DOM. You aren't escaping that. Sure, in some cases you can avoid component re-renders, but optimal code would do that as well and without the additional overhead. To answer how signals get better performance is fine-grained rendering. It's what you can get rid of, using the reactive graph to only update what has changed. Components don't matter anymore, no virtual DOM. I need to thank Misko Hevry from Angular Quick for this graphic. It doesn't tell the whole story, but it's a start. Think React, think Svelte 4, think pretty much every framework before a year ago. Picture some application where you need to pull state up high so it's available at multiple points, like a shopping cart in the header and a buy button deep in your page. You update the state, you trigger re-renders down the whole tree. Only the shopping cart really needs to update, but we do all this extra work. So what can you do? You can memoize. You can realize that the data you send down to the buy button isn't changing and only run down the one path. Much better. This is what Svelte 3 and 4 did automatically and what the React compiler will do for you. But if the cart has changed, there's no void rerunning all the components from owner of the state down to the change. We can prune branches that didn't, change along the way, but the change has to reach its place in the UI. But what if you could just, now you might be thinking, yeah, I can do this with Jotai or my signals in React. And that's true to a degree. But the point at which you use the signal, you enter the tree and that becomes a new route. However, with fine-grained rendering, all props just work this way by default. You can declare state at the top of your app, have it pass through a few components, and get this exact same result. And it doesn't need to rerun whole components or parents or just the parts that change. The whole category of will my component rerun goes away. Performance with composition becomes a non-concern. The takeaway: when the dependency is decided on read rather than on write, your application has a lot more knowledge on how to update. The other takeaway should be that absolute performance isn't the most important thing. But I still want to highlight that it's real, and it's a product of architecture, not effort. This year, 2 other frameworks for the first time have actually joined us on the fine-grained rendering train, Svelte and Vue. I think they may have even improved things slightly on our 7-year-old implementation. So if we haven't been looking at performance with Solid for 7 years, what the hell have we been doing? Glad you asked. Lots of work into building out our ecosystem, but a decent amount of work into understanding implications of this render model. Everything from HMR to SSR to hydration has never been done before with this model. We built a meta framework, introduced the world to server functions, single flight mutations, but more recently, we've returned to our roots, reactivity. So let's talk about the next topic here. I want to talk about mutability. I think there's still some non-believers here in the audience. There always are. Mutability is often seen as some evil, especially from functional programming side of things. I looked online, and apparently they make t-shirts and stickers like this. But this is one of those topics where compilers and VDOM libraries can't really easily follow. It's honestly what started me on Solid in the first place. With mutability comes stable references. You don't need to clone everything along the path of change. It just means less work, which is good for performance and good for your sanity. It's not that they don't have a point in terms of unchecked mutation, but control mechanisms like read-write segregations do 95% of the work here without being immutable. And it isn't like immutable doesn't have its own issues of traceability. Ever so often you hear a horror story where someone has used use effect to DDoS themselves. Usually it's a business or a user racking up infrastructure costs, but when it's Cloudflare, a company itself known for DDoSing, it gains attention. Now, this could have happened with any framework. Loss of referential equality on dependencies cause signals to over-execute as well. But there's a reason this tends not to happen with fine-grained solutions. Many, but not all signal frameworks have a mechanism for creating deep reactivity. This is an important part of the solution. In Solid, we call them stores. They are proxies, which each property has the potential of being its own signal. And this has consequences. A signal like state in React is generally immutable. But a store, being nested, keeps references for what hasn't changed, and in so is mutable. This is important because we don't want to over-notify when things change. If you update the street number of an address on a user, we don't need to tell the user it's changed. Each field updates independently. It's why the DDoS is way less likely to happen, and why when you update the state of the done on like a toggle on a to-do, we don't need to rerun any components or do any diffing. The data can get to the leaves without recalculating everything in between. But stores are way more important than managing granular updates. Some problems just lend to diffing. You get fresh data from the server. There's no shared references there. If one was to naively just set a signal with all that data, you'd rerun everything. Stores give us the ability to automatically diff data and only update what is changed. But as you might have guessed, there's a reason VDOMs diff UI. What if you don't use all that data? Diffing is pretty wasteful. Well, that's what the reactive graph is for. We know what's being listened to. We don't need to diff all the data, just the data that has subscribers. So just picture this. You get fresh data, update from the server, it replaces the old data, it diffs along the path in which your app subscribed to, and only trigger updates in things that have changed. No components rerun, and only what has changed does run again. I've enjoyed working with stores so much in the past few years. I started realizing they were really talking about a different sort of reactivity that hadn't been readily explored. It made me realize there were gaps. There were problems that required driving granular data. There were places where you start from a single source, but want to fork or split the reactivity. It's a waste to check every row when you're changing the selected class on a table. But it isn't always practical to include an is selected on every row of data, especially if that data is shared. Sometimes we need to project the reactive data onto other reactive data without mutating the source. Sometimes we need to be able to create ephemeral state extensions of that data, like merge in, say, optimistic changes without committing them. So we've been developing a new primitive for just that. We call them projections. And while you probably won't use them often directly, we've never really had a good solution for this in the front-end framework space. A primitive that's both, mutable, granular, and derived. Being derived is important because it removes the need for synchronization and like using effects to write to state. Effects really should be the end of the loop, the exit of the system. And it means that mutating it won't mutate the underlying source. Being granular is important as it means we finally have a way to fork reactivity. Memos converge reactivity down to computed values. Projections expand and split reactivity back to multiple sources. If that isn't clear to you yet, that's okay. I'll show this off a little bit more later. Speaking of reducing the need for side effects, it became pretty clear over the last few years that derived signals you can write to are pretty necessary for keeping state without needing to call effects to set them. And honestly, we're not the only ones. I believe both Angular and Svelte have these kind of linked signals. I used to call them writable memos, but these days I just call them signals, because in the next major version of Solid, you'll be able to derive a signal from something else, say like props, by just wrapping it in a function like I have in the second example here. That'll automatically update the signal whenever the prop name changes. And now that we have projections, we can actually also derive stores in the exact same way. But probably the most important thing to avoid unnecessary effects is having primitives to manage async. So on to our next topic. I know I'm going very fast here, but I have so much to show you today. And it starts with understanding the role of async in UI frameworks. There's a lot of tools to help handle async better, process events or streams, etc. But for a UI framework, all we really care about is maintaining consistency within what we display. UI frameworks tend to be synchronous to provide guarantees, and so are signals, which make them a great choice. We only care about async at the edge of how it enters and exits our system, what we need to handle to maintain our synchronous model. And yeah, as I said, it always comes down to consistencies. These are all valid options, all four here. Show placeholders, hold in the past, show the future, or don't be consistent tearing. Like even tearing, which is inconsistent, is an option here. Ever use a type ahead? That's generally a form of tearing. Each only applies to certain scenarios though. You can't feasibly show the future for data you haven't loaded yet, but for data mutation, you may have enough information to mock it. That's what we call optimistic UI. Similarly, there are challenges to staying in the past, because how do you load the present or the next state if you can't update that state because you're showing it on the screen? Do you duplicate it? How do you know how do you let the user know something's happening in the background? And then, showing a placeholder, well, it's pretty jarring if you've loaded that data before. Ripping the UI right out from under someone is really disorienting. The truth is, this isn't a one-size-fits-all, and any of these as defaults has an issue, which is interesting because different frameworks have made different choices here in terms of defaults, but all of them should handle all four of these situations. But what does any of this have to do with signals? A UI framework's only responsibility is UI and only needs to block when it doesn't have the data to render it. This flips the conventional model on its head. Async is about reads, not write. We're so used to set state or assign value rerun component. But async is more like asking the question, can I render this yet? Is what I'm showing out of date? Look at them API-wise, suspense or wait components or the use hook. These are all reads. Know what else is all about reads? Signals. The way signals can be read independently anywhere in your app, well, that's a superpower. For us, this starts with introducing an async primitive, a derived async signal. It doesn't need to be derived, but at its core, it tracks sources and reruns when they update, while communicating that the value isn't ready to the rest of the graph. And this is powerful because it piggybacks on all our fine-grained benefits that we already have, which brings us to our first demo here. This is kind of a basic demo that I've set up in a playground using some Solid 2.0 code, but I just want to kind of show the idea of this demo. Basically, we have a component, function A, and I'm using some stuff for tracking. You'll see why in a minute. But each component fetches its data, which basically just fetches time in 2 seconds, and then it renders its information depending on that time. See, we have this async value that we get the time difference from when the page loaded, and put it in here, and it also renders a child component. B similarly looks very the same, except it renders C, and then finally C at the end just renders its own information. But each one of these fetches its own data in cascade. A fetches, reads that data, renders B, fetches, reads that data, C, and so on. And I put the whole thing under a nice little suspense boundary. And I drew them so you can kind of see how they sit in each other. But what you're going to notice is we're going to load the page. We're loading. And maybe you might not expect this, but they all load in 2 seconds, even though the fetching takes 2 seconds. They all actually render in parallel. And the reason for this is because we're fine-grained. We only need to block this expression. We can continue to render its children, even though the async is blocked right here where we render it. We can push it down to the reactive expression, fine-grained style, which is super powerful because it turns children into siblings, essentially, which means that if you're not blocking in the UI, you don't have to block the data fetches. You can nest the fetching wherever you want in your components, and as long as the data isn't dependent on each other, it won't be blocked and it'll fetch in parallel. This is what fine-grained gives you. If you had to like use in a component or something, it instantly becomes blocking. So this is why I'm so excited of using reads and for signals for async. Okay. But it's more about than just being fine-grained. Signals are both push and pull, which gives them an advantage. Like when you have events which are push only, they only know what has updated, but they don't know how it's used. They don't know if anyone's actually listening to that event. Or say only pull-based, like a BDOM, it knows what's being used, but it doesn't know what's updating without checking everything or diffing everything. With signals, we can have both. And we should be leveraging this knowledge a lot more. I actually have an example of how this is super powerful. Got to thank Dev Agrel for this demo, but essentially what I have here is we have a signal here that sets count. This is our counter example. I always go with the classics. And it triggers async fetching, which returns a phrase that goes with each count, 0, 1, 2, 3. It also has a chance of erroring out randomly. Every 30% of the time, it has a random error. So we get that. We derive some data. We make it uppercase. And then we pass it down to our message component, which renders it. First thing you're going to notice here is that our suspense and error boundaries are below the fetching. Again, because we don't need to block until where we read. So suspense just has to be above where we do our data fetching. And then our error boundaries can catch the errors in case the async errors out. Inside our component, the props are normal. There's no promises. It's not aware that it's even really an async component, other than it has the ability to show a loading state for our purposes. But generally speaking, because the framework already knows how to handle signals, and a component already knows how to handle async. So I'll just refresh the page so you can see it loading the phrase, and then we have our 0. Now, what we're going to do here is we're going to click on it until it errors, which 30% of the time it should error. Sometimes we get pretty far without it erroring. Come on, error. Oh, damn it, I went too fast. Okay, that's fine, we're here. So we error message random async error. Now, you notice that the error boundary has a retry. What do you think happens when we click this retry button? Well, it tries to re-render or update the what's errored down here, but that would just error again. And this is the case in most frameworks. But look what happens when I click this retry. It's actually refetches the value. And the reason is because it knows a reactive graph. When it pulls the value, sees that the node has failed, it goes, okay, why am I failed? Oh, upper phrases failed. It walks back up the graph. Why did you fail? Oh, phrase failed. Walks up the graph. Phrase goes, oh, I'm async and I failed. Let's retry it. So we can basically use the graph to self-heal our async here. And also in the case of, we can also use it the other way too. If we don't click reset and we just click the next number, it also has the ability to heal itself. I think what's really powerful about this, and I'll show this really quickly if I can, is when I refresh the page, you see that we have console logs for when it renders the original components. See on the component body here, rendering phrase counter. Obviously this is fine-grained, so whenever I click it, generally it'll fetch. Oh, it errored out. When we retry, we actually still don't end up re-rendering the components. Like suspense, error boundaries keep the nodes off screen and then just fix the parts that errored out along the reactive graph. So we have fully healing data fetching and rendering without re-rendering any components. Pretty cool. All right. So back to the topic of consistency. As you can see in our last example, Solid actually tears by default after initial load. When I click the number, I mean, I can show really quick here, but when I click the number, it moves before the data loads in. That's kind of the default behavior after initial load. It doesn't, even though it does that, it doesn't tear internally in the graph. If async depends on other async, we won't fetch the second before the first results. We only tear in the UI rather than just freeze it or going back to loading states. So what if we want to hold values in the past while we do work off screen? Well, like React, we have transitions. And transitions are great because they also can tie together mutation and async fetching to remove weird race conditions around your data and pending states. So I actually have one last demo for you today. I hope this ties everything together for you all. I'm going to use all the features we talked about today to accomplish something pretty powerful. And it starts with a demo I hope you've all seen in the past, To-Do MVC. Everyone's built or played with a To-Do app. I think it's very illustrative of like what it feels like to use a framework. And here we have a store, fine-grained store, where we hold our to-dos, and then we have a method to add to-dos, remove to-dos, and toggle to-dos. I got rid of all the extra functionality to keep this simple. Whole example fits in a single component in 80 lines of code. But generally speaking, we have the header, we have our input, where we on key down, we add to-do, and then we iterate over each item, set a completed class if it's completed, checkbox, thing, and delete button. Not much else to it. So, and you've seen this thing before, right? Hello world, yes, whatever. And then we can toggle, we can remove items. Okay, that's our to-do app. Now, here's the challenge. We've all built this before, but now we want it to have a server backend. You saw like when I refresh the page here, if I go, hey, and I refresh, our data's gone because this is just client-side app. Now we want to persist it, and now we hit async. So how do we do that? Well, I made a silly mock backend. It's made it with using local storage, so it's not an actual database, but I've set 400 millisecond delay times on both saving and fetching the to-dos to make my example work. So this is where we get to use the stuff we've seen today. So first we can use create async, right? And we can use that to, what do they call it? db.getToDos. We can use that to get the to-dos. Now, you might be thinking, how do I get that into my store? Well, you can drive it, right? In the same way that we can drive signals, we can, I shorthanded it, but I guess to be more explicit, we can do this, right? We can go data. And now, if, sorry, I haven't got HMR working on this demo, we can see that we're actually loading our data from our server. But the rest of the app didn't actually have to change here. And then I can, add stuff to, hey, and it continues to work. Now, obviously, if I refresh, it didn't save it. So we actually have to add the ability to save it. Now, you might be thinking, okay, well, let's do this. And then we go db.add to do. And then I'm just going to go like then I'm going to go create async actually has a refresh function on it, which lets it refresh the data. So I think this should work. Let's hope that works. Let's go here, hello, and then I'm gonna go, hey, and it shows up, and if I refresh, they're both there. Beautiful. Logic all still basically works, but if you notice, there's a delay between when I said like, let's put like, okay, yo, it's gone, but then takes the thing to show up. Can we do better than that? And there's also probably weird race conditions. So I'm actually going to jump a little bit ahead here and show kind of the completed code. But what we can do is two things. We can take our async data that we just fetched, and we can change our store into something called optimistic. And with optimistic, what this does is it tries to put the data in right away. And what we can do is we can actually keep our same methods that we had before to set the store as our optimistic updates. And then we can use a transition to do our operation and call our data refresh. For example, add to do yield. I'm using a generator function here. We also support async, but the problem is you have to resume it and have to call it again. This is something also in React, so we're playing with syntaxes here. But the idea here is you set the optimistic state, you do the action, and then when it's done, you refresh the data. And with this, we actually have the ability to get rid of that, right? We can say, hey, it shows up right away, and then it loads, and it also saved it too, because when I refresh in the background, you're going to see that it actually saved both of these. So we can essentially get immediate feedback and load our async. And we didn't have to actually change any of our logic here. I did add a suspense boundary just to show that initial loading state, but our logic in our component actually didn't, like view, template JSX didn't change. All we did, and even our logic for how we updated the state in the client, it actually is the same logic to do optimistic updates. In fact, we just had to rename a primitive. And then we just add our async logic from the database, and everything just works. And what's really cool, as I said, about this whole deriving setup is this is using a projection under the hood. So when the fresh data comes from the server, it actually diffs it in the background here. into our store. So if our optimistic updates match our future UI, like they do in this case, no additional work runs. We just basically do the fine-grained updates when we set the to-do here. As you can see, this is push. We're not running the whole list. We're just adding an item. We're just toggling. We're just setting checked on one item and doing those fine-grained updates. And then when the data comes back from the server, it matches the data against the data, sees nothing else changes, and doesn't run anything. This way you get the best of basically all worlds. And that's mostly what I wanted to show today. I could demo off a lot more of these features, but you start seeing that how these pieces play together is actually incredibly powerful. And I'm really excited to see other frameworks continue the research in this sort of area. The power of using the reactive graph can't be understated. And I think this is going to lead to a lot of innovation over the next couple of years. If you like what you heard, you can always find resources you need off solidjs.com. You can find me on X at Ryan Carniato. And if you like nerding on JavaScript frameworks, I stream weekly on YouTube and on Twitch. Thank you.
We're back. Fantastic talk. I'm not muted. No. I also want to use this time to plug your JSX, somewhat TSX proposal. That was a super interesting read. As a company that works on dev tooling, I would love to see that happen. So
that's cool. Here, I'm not really sure if people are interested. It's really hard when you have something so adopted by tools everywhere that like it's built into TypeScript, ESBuild, Dino, all these things, and you're like, but the problem is it's not improving. It's been 10 years, Yeah.
Coming to your talk, there are probably a million questions that I would like to ask you, but that feels a little selfish. So that was a great question. How do you feel signals compare, or like proxy-based signals compared to like non-proxy-based signals? I can talk proxy-based signals versus non-proxy-based signals. Any thoughts on that?
Yeah, I mean they're the same thing. Like what I was trying to show in the graph there was what I was talking about stores and mutable reactivity or the proxy-based signals. When you take, but they don't even have to be proxies. Proxies is just the container it is in. If you take signals and nest them inside each other, you suddenly take things that are immutable, which signals are, like you replace the whole state, and you make it mutable because by changing a nested object, the outer one doesn't change. So proxy-based reactivity is just a convenient way to write nested signals or make it mutable. And my example there, when I use create store, when I talk about create projection, those are proxies.
Yeah. I think also pretty much all of the big signals implementation are proxy-based by now.
Well, I mean, right? they have a proxy option. See, proxies have overhead. So like there's a base signal implementation. There's like a signal or a ref in Vue, or like a shallow state in Svelte. And then a lot of them have the ability to make it deep, like reactive in Vue, store in Solid. Svelte auto does it with their compiler, and Angular has a new proposal that is coming out, I think, to add it. So to me, it's like it's not like either or, it's just an extension. So like some signals frameworks might, or libraries might not have their proxy, but someone could build a proxy version on top. Like if you have Preact signals, you could add a proxy-based implementation on top.
True.
One more
Are there more questions?
There's just this one.
Oh, that was an interesting one. I was wondering the same thing, how you distinguish async components to your async signals now, because you use them for rendering purpose, so it's like kind of blurry line.
I don't like the idea of async components, because they're like, it's like async functions. It's like they're innately blocking, right? Async await is really convenient because it lets you think of things in a synchronous scope, but the problem is they block. Like when you have async await, you're like saying, run this, stop, run this. So like when I don't think components themselves being async make a ton of sense. But it is what, like, in a sense, that's what I was talking about when React has use, or like a lot of APIs, maybe they use an async component. The reason this is so powerful is because it's not the component that's async, it's the fine-grained thing that's async. I don't want the component to be async. I want the data that passes through it to be async.
That's the thing that I like about async now, Solid so much that instead of thinking about components, it thinks about data flow more, which is a little bit of a mental switch.
Yeah. The cool thing is that once you like take that step and we make it ergonomic to use signals places, like the way we like do prop wrapping and all that stuff, the rest just follows, because you can write a component independently, look at it and go like, what's my prop? It's a number and a string or this type of object to do. You're not like necessarily thinking signals there,
Right.
but the fact that the source can be signals, can be even async, just all ends up working together quite nicely, right? Because you don't have to be responsible for figuring out where the read is to be most optimal. We will push that all the way down the graph and block at the last possible moment, which removes the maximum number of waterfalls or cascading of impacts.
That's good that you bring this up, because now I selfishly just asked my question. No, put that away. I'll just ask my question.
No, I mean, it's fine. I mean, async components, React can do async components in parallel because it can see them almost like promise all. It's like, okay, block here, block here, block here, block here. But it can't render the children because it hits that and it doesn't see that it's going to render the children yet. You know what I mean?
Right. I totally get it. The thing that I'm wondering is, because there are requests that you do want to run sequentially. There are things that you do want to run in parallel. Do you have that flexibility now with the Solid Signal 2.0 proposal? Or
I mean, the question is why do you want to run them in parallel or after each other? It's because they depend on each other. You can trace the data dependency. If you're like, look, I need this to fetch this, then I need this. Like, otherwise, why wouldn't you try and parallelize as much stuff as possible?
I have seen janky APIs, and I'm sure you did too. That feels a little naive to be like.
Okay, but I mean, if the worst came to worse, you could fake the dependency, or you could literally just like block. True. You can block. You can be like, look, don't render this until this loads in. Like in our case, we have show. And you can like try and block it. What's cool about things like suspense is non-blocking, inversion controlled. You can try, it's like kind of like a try catch. It's like you can try to render this, and unless it all renders, we're not going to show you. What's cool about the solid version is it doesn't throw it away and then try and render again like React. It actually goes, okay, we'll keep what you rendered, except we'll realize you can't quite finish it, and then we'll just finish it when the stuff comes in.
Yeah, that makes sense. Yeah. I'm super excited to play with this. This is probably the first time for the last 5 years that I really thought, okay, this might be something that changes the way I write front-end applications, in the way that architects, except for micro front-ends, which we will talk about after this. So
yeah, I mean, the tricky part here, and people like don't realize, is that the implications continue on like that. You're not building APIs around promises necessarily. Like one of the challenges is like if you fetch high in most frameworks and you want to get down low, you actually have to pass the promises through your components. You have to change the signature of your components. What this does is it automatically lets you hoist high, fetch low without changing the structure of your apps. Suspense goes where it goes. You don't have to break it out a separate component if you want to add suspense, or airbounds. You can think in terms of sections of your UI, in terms of when you build your UI, like this is where a placeholder goes, this is where error goes, boundary goes. But then you can data fetch wherever you want in the tree. It doesn't matter. Components don't matter.
That is super cool. Thank you so much for joining us. I was told in the backstage, I'm super excited, so I keep clapping, but I was told backstage that I should better stop that because it's annoying. But I'm still excited, so that's how this plays out. I want to thank you because you picked for the raffle the Front-End Master subscription, which I'm a big fan of. And I think you have a course on Front-End Masters too, on Signals and SolidJS. So again, Discord, hit that ta-da button, sign up, win a Front-End Master subscription, watch Ryan's course, and know everything about SolidJS that was there when the course was recorded.
Yeah.
Thank you so much.
Thank you.